Now we're going to talk about constructors. As we talked about instance variables here, and we said that now we have to have a way in which we can protect or limit access to our instance variables from other classes, which will make our classes their own entities or black boxes, which is exactly what we want. One of the main reasons why object-oriented programming is very popular is because we're able to create classes that are their own entities, tempered with their own data, as opposed to always letting other classes tampering directly with their instance variables. Okay, so as we talked about that, we need to figure out a way to manipulate our own data, to initialize it, and do whatever we need to do inside of our class here, right? Well, the first thing we need to do, as you can see here, all of these instance variables or properties or states or fields are not initialized, right? So we will talk about constructors. A constructor is a special function-like code block, okay? But it's not a function which is used to initialize all the necessary states of a class, or initializing all the variables or instance variables of the class. So as you can see here, we have our name, age, and height. So we need to be able to initialize those. How do we do that? Well, a constructor, it has to have the same name as its hosting class, meaning our class here is person. That means our constructor, the function-like code block, has to have the same name. So how do we do that? We say public, and we don't have to have a return type. We don't have to have void or int or boolean as a return type, because it has to directly say public and the name of, and have the same name as the hosting class. So it's going to go public person, and then our parentheses there and our braces. So this is how we know that this is indeed a constructor. And the other thing about constructor is that that's the first thing that runs when we instantiate our objects, okay? Which makes sense, because if the idea of having constructor is to construct, right, to build the class, the object, so that it's actually in a state that can be usable, that makes sense that it should be the first thing that runs, okay? Just to verify, to make sure that's true, let's go ahead and say system.out println and say here hello from my constructor. Okay, and just to make sure we don't have a lot of things here, let's just get rid of all of that for now. Okay, so let's go ahead here and get rid of this, that. Okay, let's see what's going to happen here. Okay, let's run. There we go, hello from my constructor. So indeed we have proven that the constructor is the first thing that runs. And another thing about constructor is that all classes have a constructor, right? Even if we don't actually explicitly write a constructor, just like what we did here, all Java classes have constructors. Okay, that's just a contract that we have with Java. All of them have constructor. So we said that our constructor is responsible for initializing our values, our instance variable values, right? So our constructor here, what we can do, we can pass certain parameters, certain arguments. That way, when we create an instance of that class, an object, my person, we want, for instance, we can then have an actual person, right? So what we can do, we can pass in all the instance variables here. So we can say string my name and pass in int my age and int my height. Okay. And now to initialize those, what we can do now, we can go back to our instance variables, because we need to initialize those, right, with whatever we're passing inside of our person, inside of our constructor. What do we say now here? We say name, right? Notice name string person. Which one is this? Well, is this name here at the top, the actual instance variable, is equal to whatever we're passing here for our name. So we can say my name, okay? And then we say age. Well, what's age here? Well, that's this age here, our instance variable, is equal to my age. Height is equal to my height. So now what we're doing here, we're saying, okay, so we're taking our instance variables and we are initializing them with what? Well, with whatever we are passing in as we create, as we instantiating the actual object of type person. So notice we have an error now. Why? Well, because it's saying, well, you've said here that in our constructor, in the explicit constructor that we created here, we need to pass these variables, these parameters, so that we can construct, we can create the actual person object. Okay, so that means here we have to pass something because that's a contract here. Because earlier, when we say just new person, it was using a constructor. Actually, going back to the idea that all classes in Java have constructor, whether we explicitly write those constructors or not, when we did this new person earlier, before we had an actual constructor, well, what we were doing? We were running the constructor that comes with Java already. It's just that that constructor had nothing in it. It did not have anything inside like the one we just created. Does it make sense? All right. So now here, since the contract has changed, we are actually not saying, we are saying, well, our constructor has to have these parameters here. Now we have to honor that contract. So if we click inside here, so we get to match. So that means the first thing we need to pass in here, what was it? It's the name and then int. Okay. Name, we can put George. And then we can put, and then for age, we can say 72. And height, let's say 6. Let's say 6 for 6 feet. For us to see that this actually works inside here, we can then go ahead and say name is and pass all of these values that we have initialized. We can say name, my age, and finally we can pass in, can say name, actually here should be age, right? And then we can pass in height. If we save this and run, look, name is George 72.6. Give a little space there. Now, you may ask, well, why are you using the name, which is the instance variable that we created at top here outside of our person constructor, instead of using the actual, instead of using what we've passed in here? Well, let's see. If we put my name here and save, it will work. Name is George 72.6. That's fine. The reason why I'm using the instance variable instead of the variable that we pass in here, which is the same thing, because as you remember here, what are we doing? We're taking our instance variable and initialize them with whatever we're passing in here. Because the idea is to be able to use this name instance variable, which now has something, because we've created here, right, outside here. Because now here we can create, that's the beauty here, we can now create another behavior, another function. We can say, for instance, public void show name. Guess what? If I just say system.out.println here, I say name. If I actually just go and use the name, our instance variable, look what's going to happen. Look, I'm even able to get to it, which means now what we can do, if we go back to our my person here and say my person dot that show name, guess what's going to happen? Run. There we go, name George. Well, what's happening? Well, because I created now another behavior, another function, a behavior function, right? And now I'm accessing our variable, instance variable, which, as we know it, was initialized inside of our constructor, which means the entire class now has access to it, okay? Let's change this to private, like all of the other ones. The result is of course gonna be the same, but the whole idea behind all of this is the fact that now our name, our age, our height, they're all visible inside of our person class. Because now, since all they are private, again, if we go back here try to say my person dot age, you see nothing shows because they're all private, which is exactly how it should be, because we only want to be able to access these instance variables inside of our person class only. Manipulate everything inside here as opposed to getting outside. And obviously here, what we can do to finalize, we can just take all of this and paste it in here. That way we don't have anything inside of our constructor but the construction of the object, and then here we're showing what we have constructed, what we have initialized it. Okay, so we save this, nothing's gonna really change much except that our show name will now be responsible for showing the name and of course all the data that we have for a person, our person class. Now you have stepped up and learned something a little bit more of about classes and object-oriented programming. So we are progressing and learning really what a class is and how to create solid and dependable classes, right? How to hide data, so that way we are not letting any other class to directly tamper with our instance variables here, because of that way we don't run into issues. And this is the beauty of object-oriented programming, is the fact that we are able to do this. We're able to make sure that our classes are their own entities for real. They do all their work and we don't have to worry about it, because they're just their own black boxes that we can use to create other classes from them and work with other classes, make classes working together. But none of the classes need to necessarily tamper with each other's instance variables, which is wonderful. Okay, in that process, it makes our classes very protected, makes our classes much more organized, and also preventing the misuse of classes. Perfect. So I'll see you in the next video, and we'll keep talking more about classes and other aspects that are very important, especially as we move forward into the object-oriented programming. All right, so I'll see you in the next video.